So we're going to start off by looking at what do perfect squares have in common and how they work. So if you look at the first example in the book, it asks you to take the factored form. Notice that these are all perfect square examples because they are squared. So what that means is that when I write the factors, both factors are going to be identical. Because remember, that's where we practice, stretching it out and then just writing them both. So then it asks me to distribute. Give me another name for distribute. Foil. You're just multiplying in foil. So now I'm going to multiply x squared plus 1x plus 1x plus 1. So now I'm going to write it in standard form. That means that I'm just going to combine terms. So this is going to be x squared plus 2x plus 1. So let's do the same thing for the next one. Let's take this. Let's expand it into our two factors. Again, it's a perfect square. Distribute. And I'm going to be honest, do we really have to do this? No, most of us can do it in our head, so we know that this is 4x plus 4. If you have to, sure. But if you can do the middle in your head like I do, I just write it. So then do the next one. X squared plus 6x plus 9. So keep working them. I'll give you about a minute. Finish them. I'll do mine. You do yours. Okay, so now we want to look at what do we notice when we compare the factored form to the standard form about perfect squares. What are some patterns that we notice in the numbers?
You add the same number and multiply it. You add it by the same number, multiply it by the same number.
Okay, that's the big catch. So look what he says. You take that constant in the factored form, right? And you double that to get the middle term, and you square it to get the C. So let's see if that works what Lamar just said. I take the 3, I double it, do I get 6? And then I square it, do I get 9? Okay, 4 doubled, squared. 5 doubled, squared. And 6 doubled, squared. So basically you are doubling the linear and squaring for constant. Do you agree? So when we have a perfect square, we are taking that factor and we are doubling it for the linear term and squaring it for the constant. Okay. So now let's try to work backwards from what we just discovered here. If I give you standard form and I ask you to write the factors, so doesn't that mean I take the 12 and divide it by 2 and I would get the factor?
Yes.
Because the middle is double of what the factor is, right? So let's try that. Wouldn't that be x plus 6 squared? Now, does that work? 6 times 6 is 36, and it does work. So let's try the second one. So x minus 6 squared, did that work? Half of 12 is 6, it's negative, and then 6 times 6 is 36. It worked. All right, what about the third one? What is 20 divided by 2? 10. So does 10 times 10 give me 100? Yes, it does. This is a plus, so it's going to be x plus 10 squared.
Oh, damn.
Yeah. Hold on. So now we get to this one. What's 3 divided by 2? 1.5. And it's minus because that's what's there. And then 1.5 times 1.5, is that 9 over 4? Yes, it is. You would get the decimal version in your calculator. All right, what about this one? Half of 100. 50. So x plus 50 squared is 50 times 50, 2,500.
Yes.
Okay, let's go to the next one. 8. What's half of 8?
4.
4. And it's plus x plus 4. 4 times 4 is 3. No, it's not. What just happened?
We didn't get a pair.
You did not have a perfect square quadratic. That only holds true for perfect squares. So what we're going to do is we are going to use that knowledge to force quadratics that are not perfect to be perfect. Okay? Turn the page. So if you notice, there's no fluff on this. It's 2 pages of problems. Because, no, that's me. That's why I like algebra. I don't like all those word problems. So if I look at the first one, the challenge is, can we make an expression that is equivalent to this, that is written in a perfect square? So if I have this, I know that half of 8 is 4, correct? So if I wanted to make that a perfect square, I would say that it would need to be x plus 4 squared, correct? But that would give me 16, not 3. So what would I have to do to 16 to get 3? Subtract 13. There's my vertex form. So I just forced it to equal this. But you're like, Ms. Blanchard, how do I know it equals that? Well, if I multiply this together and subtract 13, guess what I get? And factored form, if it doesn't work, you can complete the square and get it into vertex, and you'll know, okay, what is the transformation that has to happen to get it correct? Now, tomorrow, what I'm going to do is I'm going to show you how to take this and solve for the roots from it. That's why I'm not putting the criteria up today, because I'm going to wait till tomorrow and we'll do it all at once. So today what we're going to practice is we're going to practice how do we get to this. Now, I just did it with no fluff and stuff. I just said, okay, what would make it perfect, and then how would I get it to that? But there is a box method that helps. So let's look at number 1. So what you do is you draw a 4 square. Now, I want everybody to try it for a couple problems. Then if you could do it in your head, that's fine. You take the first term and you split it. You take the middle term and you divide it by 2, correct? So that's going to be 2 and 2. You then multiply. So a squared, 2a, 2a, and this would be 4 as my perfect. All this did was make you create the perfect square. If you can figure that out on your own and know that this is going to be a minus 2, then you're okay. Does everybody see that? Now, what do I do to 4 to get 15? I add 11. And I've completed the square. I've made it perfect. So this is perfect with the added piece to make it perfect, to make it equal to that. All right, let's do the next one. You ready? Draw your box. Split the first term, n and n. Go to the second term, divide it by 2. 1 and 1. Unfactor. N squared, 1n, 1n, 1. Now, what's my perfect square? This is a negative, so it's going to be n minus 1 squared. Now, what do I do to 1 to get negative 15? Subtract 16. So the question you're asking yourself is, what do I do to this perfect square number to get that negative 15? Well, I would do negative 16 and I would get negative 15 because this is a positive 1. Okay? Let's do another one. Okay? See, I can look at this and go, it's n plus 10. And that 10 times 10 is 100. And I know I got to get this to 100, so it's going to be negative 140. So I can do it in my head, but the box does help you organize it. Or if you have to prove your answer, the box would do that. So I take the middle term and I split it. Now I factor it into my box. N squared, 10n, 10n, 100. This is a plus. So it's going to be n plus 10 squared. Now, what do I do 100 to get negative 40? I subtract 140.